This video is for 6.3 probabilities when each observation has two possible outcomes. After this lesson, you will be able to complete week 7 homework part 2. Okay, this will be the last video of week 7. And I also posted, and if you noticed, I also posted the blank PDF of the note that I'm going over on Canva. So if you would like to download this, print this, and go through the notes with me as I'm going over the slides in this video, that's how we usually did our class when we were meeting face to face, right? So this one, as you can see, is about 1, 2, 3 pages. I have some examples. This can be much longer if we are using the formula by hand or the table method, but I'm going to just we're gonna go ahead and just use StatCrunch to calculate the probability, the binomial probabilities. We're gonna use technology, so this will be a little easy, and just like how on the take-home exam from now on you will have access to your StatCrunch, so I figure that we can just do it that method. Okay, so we'll be using StatCrunch, so I will go through these slides. When I see these examples, I will open up StatCrunch and show you what we are pressing, which buttons, and how do we enter to find the answers to these probability questions. Okay, alrighty. 6.3 is about probabilities when we have two possible outcomes, just two possible outcomes. It's also called binomial distribution, like the prefix bi, two. And what we first have to do is talk about, well, let me read the learning objective first. So in this lesson, we will use the binomial distribution to calculate probabilities. And we will be using StatCrunch in order for us to find these probabilities, okay? I call it BINS, B-I-N-S, for 4 conditions for an experiment to be considered binomial. The first B is for binary, and I typed it up at number 3 here. Each observation represents one of 2 outcomes. It must have 2 outcomes, okay? Binary outcomes, either success or failure, or yes or no. It needs to be clear. It's either one or the other, okay? BI is for independent. So each observation must be independent. That means the result from one observation doesn't have anything to do with the result of the second observation, or so on. The third one, or I think I'm gonna probably change the order of this, but the number of observation n must be fixed. Number of observation n must be fixed. So for example, imagine flipping a coin. If you flip a coin, you can get either head or tail, right? So that's a binary outcome. But say that you're flipping this coin exactly 5 times, then the little n will be 5. You have to have that fixed number of observation to be considered a binomial experiment. You cannot say, I'm going to flip a coin until I see 10 tails. You have to make sure that you start with a fixed number of observations. And the very last one, the probability of success, P has to stay or remain the same for each outcome. Say that you flip a coin, guys. There is a 1 out of 0.5 chance of you getting a tail, right? And that 0.5 will remain the same the second trial, the third trial. So that probability of success, which we will use little p, that must stay the same for each outcome, okay? So let's look at 2 examples of different cases and determine whether that's going to be a binomial experiment or not. Before we do that, let me give you some notations, okay? So like I said, little n represent the number of times a trial is repeated. So say that you're flipping this coin 7 times, then the little n will be 7. Or if you're looking at whether a surgery is successful or not successful in exactly 5 patients, then little n will be 5. P represents the probability of success. So if a surgery has like 75% success rate, P will be 0.75. Q is the probability of failure. Now, in a binary situation, when there's only P or failure or success, P and Q must add up to 1, right? Either you succeed or you fail. So in order for you to find Q, you simply have to do 1 minus P, and we can look at examples in a couple slides. What we really need when we are finding the binomial probabilities in StatCrunch is N and P. That's really all you need. And of course, you have to give them what X is, what you are interested in. X represent the count of the number of successes in a trial. I may ask you questions like this. Out of 7 surgeries, find the probability that exactly 2 surgeries will go successful. 7 will be the little n, and 2 will be the X value. But, these are all coming, but I just wanted to give you these 4 letters that we use to notate binomial experiments. Let's look at the first one. Number 1, a surgical procedure has an 85% chance of success. Okay, so P, the little p will be 0.85. A doctor performs the procedure on exactly how many? 8 patients. So that's fixed there. The random variable represents the number of successful surgeries. So what they are saying is, well, you can have 0 successful surgeries, 1, 2, 3, 4, 5, 6, 7, or in a best case scenario, all 8 patients will have successful surgeries. So X varies from, X ranges from 0 all the way up to 8. Now, this is a binomial experiment with N of 8, because we're performing the procedure on exactly 8 patients, with p-value of 0.85, right? P is the probability of success. 85% in decimal is 0.85. So what about Q? What about the probability of failure? How do you find that? You have to do 1 minus 0.85, so Q will be 0.15. Now, I did not type this up here, but you can write it too on your paper. X can go from 0 all the way up to 8. And this is an example of a binomial experiment, because whether a surgery is going to go either successful or not successful. We're talking about performing on exactly 8 patients, so that number of observation is fixed. The probability of success, that 85% chance, will remain the same, and each cases are going to be independent. Just because patient 1 and patient 2 and patient 3 had a successful surgery doesn't mean patient 4 must have a not successful surgery. So this is an example. Let me show you another one. Now this time, a jar contains 5 red marbles. I think I'm going to start writing some things down as I'm talking about this, because I want to talk about the actual probabilities. Hold on, let me get my notepad. So how many red marbles? We have 5 red marbles. We also have 9 blue marbles. And how many green marbles? 6 green marbles. So how many are in a jar right now? Altogether, if you do 5 plus 9 plus 6, you have 20 marbles altogether in this jar. So we have 20 in a jar, and let's see what we are doing. You randomly select 3 marbles from the jar without replacement. Take a look at the word that I highlighted. Without replacement, what does that mean? That means the first time you reach in to grab a marble, well, there are 20 marbles in there, right? Now you take one out and you look at it. The second time you reach in to grab another one, how many are in there? Not anymore 20, right? You took one out already. So you're down to 19 marbles in there. And this is never going to be independent. Well, the third time you reach in, there's only going to be 18 marbles left in there. Now, let's see what we are interested in. The random variable represents the number of red marbles. Number of red marbles. So let's talk about the probability of red here. Probability of red. The first time you reach in, how many red marbles are in the bag or in the jar? we have 5 out of 20 total, right? So that chance is approximately 20% that we're going to get a red marble. Say that you reach in the second time, let's assume that we got one of the red marbles out. If we got one of the red marbles out, then we only have 4 left in there out of how many total? 19, right? And 4 out of 19 is not 20%. Notice how the probability of red changes in each trial. Therefore, this is not going to be binomial. Even if you assume that you didn't get the red marble in your first attempt, the second attempt will be 5 out of 19, which is different from 5 out of 20. So this one, what we want to mention is that this is not binomial because that probability of success will change in each trial. And the reason it changes is because we're doing this without replacement. And we can think of a couple other reasons why this may not be a binomial, but that's enough. We found one reason for it to be this is not a binomial experiment just because of that one reason that it didn't satisfy, because it must satisfy all 4 of those conditions right here. To be binomial experiment, all 4 of them must check. Okay, alrighty. Now, let's actually calculate some binomial probabilities. And from now on, all the examples that you will see will be binomial experiments. So we can find N and P, and we're going to actually use StatCrunch as our calculator, okay? All right, so this is where you will go. On your MyLabs, you will go to StatCrunch and go to Stat. Go to Calculators, and the second one under Beta is going to be binomial. This is where you want to go for all these binomial probability calculation problems, okay? So, and we'll do a couple together, all right? Let's look at a first example. Finding binomial probability example number 1. Rotator cuff surgery has 90% chance of success. I see what I need here. Little p equals 90. The surgery is performed on 3 patients. Look, we know little n is 3. We're only going to perform on 3 patients. So the number of observation, n equals 3, and p equals 0.9. N equals 3, and p equals 0.9. Now, what do we want to find? Find the probability of the surgery being successful on exactly 2 patients. So what's x? X is 2. Now we're going to find the probability of exactly 2 surgeries being successful using StatCrunch together. This is a binomial case, and all you need is n, p, and x, and we're ready to go into StatCrunch. All right, let me go to StatCrunch with you. Go to MyLab and Mastering, and when I give you an exam, it's going to be a take-home now. You can do this, but I do need you to definitely label what your n, p, and x are, okay, when you are doing binomial probability, instead of just giving me your final answer. I may ask you to attach a screenshot of something. I didn't really think about exam 2 just yet, but where am I going? Oh, I'm going to StatCrunch, right, StatCrunch. All right, in StatCrunch, the middle one, it always does this. I have to close this and try again. And the second time I open it, of course it works. At least it did before. Let me click it one more time. Okay, I got it open. Maintenance Saturday. Oh, they're having a maintenance on Saturday. Oh no. No, that's okay because your assignments are due on what? Thursday. So you'll be all right. Open StatCrunch and go to Data. Oh, no, I'm sorry. Stat, Calculators, and Binomial. Click. Here we're going to enter N, P, and Q. I hope you can see everything clearly. N is what? Exactly 3 patients that we were performing, right? And the rotator cuff surgery had a success rate of 90%, I believe. But let me double check. P was 90%. And we want to find the probability of the surgery being successful on exactly 2 patients. So make sure X is equal to x equals 2, and you hit compute. The answer is 0.243. That's what you can do. You can use this binomial calculator. There is a formula that you can use by hand if you want to. Well, we'll see. Because this is one method and it works great for us. We are allowed to use this. All right, so that's the answer. And I took a screenshot of that over here. And I identified my n, p, and what x is. And notice is x is exactly equal to 2. So I said x equals 2 over here. The answer is 0.243. Let's look at another example. Number 2. A survey found that 26% of US adults believe there is no difference between secured and unsecured wireless networks. You randomly select 100 adults. Okay, so I know my n is 100. P is 0.26. And X, I got 35 here. Why? Let me see. Oh, it's because we're looking for the probability that exactly 35 adults believe there is no difference between secured and unsecured network. We're going to use technology to find the probability. So let's go enter N equals 100, P equals 0.26, and X equals 35 on our binomial calculator. So I'm back here. N equals 100, P equals 0.26, and X is exactly what, 35 I think it was, and I'm going to compute. So the answer is going to be very small. Now, you may get some of these very tiny answers on your homework, and you know how my stat lab can be pretty particular about the way you round. So just be careful with rounding, okay? So the probability is going to be 0.01157, and it's probably because about 26%. No. I probably shouldn't say that just yet. But let me double check if I enter the right numbers first. N is 100, P is 0.26, and okay, X is 35. So looks like I took a screenshot of that already. So let me just come back to my slide and talk about something called the mean of this distribution. Do you see how it's this one? We had more data. We had let's say we had selected 100 adults, so this one's a little bit bigger, right? This one we have more. Notice that this distribution is centered around what number? Where do you think the mean or the median? Because this is pretty symmetric, right? This is pretty symmetric, and we'll talk about how as n gets big, anything greater than 30, it will turn into like a bell-shaped normal distribution. And here n was pretty big, n was 100, and as you can see, this distribution is symmetric with a center around probably 26, right? Slightly to the right of 25. And take a look. I'm going to talk about how to find the mean of a binomial distribution later. Mean of a binomial distribution is going to be simply n times p. Take a look. If you do 100 times the p, 0.26, 100 times 0.26 will give you 26. And that's actually the very last slide that I want to go over with you. But mean of a binomial distribution is going to be n times p. And just talking about something that you will see later. All right, but let's focus on finding probabilities for the next couple too. Now this one's a little more challenging because sometimes it's not always exactly how many numbers. I may ask you to find the probability that, look at B, at least 2 of them respond yes, or number 3, probability that fewer than 2 respond. So let's look at this one together, but we can still use the same tool. A survey found that 17% of US adults say that Google News is a major source of news for them. You randomly select how many adults? 4 adults, and ask them whether Google News is a major news source of news for them. So let's identify what N and P's are first. N is 4 because you asked or you selected 4 adults, and P is going to be 0.17 as only 17% said that the Google News is a major source of news for them. All right, so let's do the first one. The first one you know how to do already. Exactly 2 of them responding yes. What will you enter? N is 4, P is 0.17 and X equals exactly 2. So if you enter that, you will get the probability is 0.1194. And that one is exactly like how we did number 1 and 2. Now that one, if I ask you for exactly 2 or exactly 3, then you just use X equals. But take a look at the second one. It says at least 2 of them. Oh, at least 2 of them. That means we're talking about greater than or equal to 2, right? So we're talking about 2 people saying yes, or 3 people saying yes, or 4 people saying yes. So if you want to do this the way that we've been doing, you find the probability that X equals 2, X equals 3, and X equals 4, and add them all up together. Or you can simply tell StatCrunch to do this. Change the symbol to X is greater than or equal to 2, because we know at least means greater than or equal to. Now, if you do that, that probability will come out to be 0.13, and you can get the same thing if you find the probability of X equals 2, X equals 3, and X equals 4, and add them together. You can get it that way. Okay, and that's how you will have to do if you're doing this by hand with this longer formula, which I'm not going over in this video. All right, how about the last one? How would you set this up? Fewer than 2, fewer than 2. That means X is less than 2, right? So you're going to enter the same thing. N is 4, P is 0.17, but X is going to be less than 2. Now, if you accidentally use less than or equal to 2, you will get the wrong answer, okay? Now, that's how you would do it. And you'll see so many similar problems on your, not so many, because the second part of week 7 homework is only about 10 problems. But you'll see similar problems that you get to try on your homework, okay? All right, last one, last probability I want you to try. Let me read this with you so that you can stop the video and try this on your own. About 10% of workers ages 16 years and older in the United States commute to their jobs by carpooling. You randomly select 8 workers. What is the probability that exactly 4 of them carpool to work? All right, I'm going to ask you to stop the video here, okay? Stop the video and try this problem on your own. All right, I assume that you stopped the video and you try this on your own. Now, let's go ahead and go over this together. Now, what did you enter? You entered in StatCrunch that N is exactly 8, right? N is 8 because we randomly selected 8 workers, and P was what? P was 10%, so you enter 0.10 for P. And for X value, what was it? Exactly 4 of them carpooling to work, so you want the X to be 4. So the correct answer should be, it's very small, but I noticed that your My Math Lab homework also get some of these very small probabilities that you're going to have to round. The answer that you should have gotten is 0.0045927. There was no rounding rule, so I will just write the whole thing down. And if you're on the exam, you can do that too. What they are saying is because notice the probability that them carpooling to work was only 10%, right? Only 10% of them commute to jobs by carpooling, only 10%. So if we interview 8 people, what's the chance of that half of them carpool? Is going to be very low. It's going to be very low. Now, again, if you do 8 times 0.1, 8 times 0.1, you're going to get 0.8. And that's approximately going to be the mean of this distribution. But notice how this distribution is not symmetric at all. N value is too small. As N increases, let me show you. If N goes up to 10, got a little end coming down to the left here. What about if N goes to 20? Oh, that was way too big. If N goes to 20, little more turning into like a bell-shaped curve. What if N is 30? Almost, right? And if N is really, really big, let's say 100, then it's going to turn more into a bell-shaped curve. But we'll talk more about that. We'll talk more about that when we talk about normal distribution this Friday, okay? Or in week 8. Alrighty, let's go back here. We are done with probability examples. Let's talk about something called probability distribution. And we're going to construct a binomial distribution table, and it's really nothing more than just finding individual probabilities and putting them in a nice table. In a survey, US adults were asked to identify which social media platforms they use. I got a picture right here for you. 68% use Facebook, 28% use Instagram, 26 Pinterest, da 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 da. All right. So how are they making this into a binomial experiment? Let's see. The results are shown in the figures. 6 adults who participated in the survey are randomly selected. Listen, they said 6 adults. So little n is going to be 6. Whether they use the social media platform, Facebook. All right, look. So it's either them using Facebook or them not using Facebook. So ignore Instagram, Pinterest, LinkedIn, and Twitter. We're only looking at, do you use Facebook? Yes or no? So, okay, that's how they make this into a binomial. They want you to construct a binomial probability distribution for the number of adults who respond yes. So take a look. What we identified so far, n is 6 because we asked or we randomly selected 6 adults. And P is going to be 0.68. Guess where I got that from? 0.68 because 68% responded they use Facebook. So we got those two numbers, but notice how they said construct the binomial probability distribution for number of adults. Now listen, X can be anything from 0, because 0 people, maybe none of them out of those 6 adults that we asked use Facebook. That's a possibility, right? Or in the other extreme end, we may have all 6 of them using Facebook. So if I make a table, it's going to look like this. X can be either 0, 1, 2, 3, 4, 5, or 6. We're not going to have 4.5 or 7 because, we're not going to have a decimal number of people saying they use Facebook, or we're not going to have 7 people saying they use Facebook because we're only going to ask 6 people. Now, how are we going to fill out this table? We're just going to have to do one at a time. Take a look. So in order for me to find the probability that X is exactly 0, look what I'm typing. I'm typing n is 6, P is 0.68, and X is exactly equal to 0. And I just rounded that to the nearest thousandth. And that came out to be 0.001. Next, the probability that X is exactly 1, notice I only changed the 0 to 1 here. And that one was slightly higher, 0.014. If you round this, keep going. The next one, I changed the X to 2. And that came out to be 0.073. And I know if you have time, you can do this on your own too. Next one, just changing my X value to be 3. Then I got 0.206. If X is 4, that's going to be 0.328. If X is 5, the probability of that is going to be 0.279. And very last one, the probability that all 6 of them happen to say, oh, yes, we use Facebook, that's going to be 0.099. Now, that's how you make a probability, the binomial distribution table, okay? And you know what we can do is we can even graph this, okay? So if I graph this binomial distribution, it's going to look like this. So more people, we're expecting that the probability of about 4 people saying yes is going to be about the highest. And the chance that none of them use Facebook is probably going to be very low because remember, about 68% of everybody who we surveyed in a bigger sample said they use Facebook. So that's how you can create a graph of the binomial distribution. All we did was we just graphed this table this way. And you know what? You know where I got this? I actually just took a screenshot of what StatCrunch created for us. So let's do one more example, the graphing of a binomial distribution. So 62% of cancer survivors are ages 65 years old or older. You randomly select 6 cancer survivors and ask them whether they are 65 years of age or older. Now I gave you all the numbers that you need. N is going to be 6 because we are selecting 6 cancer survivors. And what's P? P is going to be 0.62 because 62% of cancer survivors are ages 65 years or older. Now we're going to have to first create a probability distribution, and then we're going to graph that table, okay? Let's do it together on StatCrunch. If you go to StatCrunch, and type in n equals 6 and p equals 0.62. And then, you know what? I'm just gonna go ahead and just put everything, maybe like 5. I'm just gonna throw random one. Because what I really just wanted was a probability distribution. And if you take a look, this picture right here, that I'm taking a screenshot of, this is the probability distribution graph, really. The 5 is highlighted in red because I just picked that, but I can just put a 0 and make that red highlight really, really small. But this is how you create or graph a binomial distribution graph. So let me just insert it right here. But if I ask you to create one, oh, not that picture. It must be in my desktop. If I ask you to create one on your exam, this is what you can do. Just take a screenshot of the graph that you get from StatCrunch, and that's really it. That's how you graph a binomial distribution. Alrighty. Now, last page. The last thing I'm just going to ask you to calculate the mean, variance, and standard deviation of binomial distribution. And a couple problems where I'll just ask you, hey, this is a binomial distribution. Can you find the mean? Can you find the standard deviation? And thankfully, we have formulas that you can use. So if it's not already on your notes, please write it down. Mean of binomial distribution is going to be n times p. N times p. That's going to be the expected value. The variance is going to be n times p times q. Now this one we have to find q. And you know how to find q. Q is simply going to be 1 minus p. Now, standard deviation, remember, is nothing more than square root of the variance. So if you want to find the standard deviation of binomial distribution, you take square root of n times p times q. Let's do one example, okay? All right, in Pittsburgh, Pennsylvania, about 56% of days in a year are cloudy. Oh, they want the mean, variance, and standard deviation for the number of cloudy days during the month of June. Now, is cloudy or not cloudy? Now, here's the thing though. We know P is going to be 0.56. That's pretty clear. They gave it to us. And now we also know Q, because we're going to need Q to find variance and standard deviation. If 56% of the days are cloudy, how many days are not cloudy, or what percent of the year is not cloudy? And that's going to be 44%, because you can do 1 minus 0.56. That's going to give you 0.44. But then the question is, what's n? How many observation is this in a year? In a year. So here, they never really gave you the number here. But, oh, hold on just 1 second. I think I know. I think I know why. I was thinking, you know what? I was thinking that n's gonna be 365. But listen, I didn't read the very last part carefully. Find the mean, variance, blah, 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 during the month of June. During the month of June. So what should we do? We better figure out how many days we have in June. And June right here, we have 30 days. So that's why little n is going to be 30 here, okay? So let me go back and present. So do you know how sometimes they don't give you all the numbers that you need to use? But we know why n is 30 because there are 30 days in the month of June. P is 0.56 because they did tell us 50%, 56% of the days are cloudy. And you see how you found Q. Q is simply going to be 1 minus, so I really just did 1 minus 0.56, and that comes out to be 0.44. That's how you find Q. So you first have to identify N, P, and Q in order for you to find mean and standard deviation. Let's find mean first. Mean is going to be N times P. So do 30 times 0.56. That's going to be 16.8. So what we are saying is we're expecting about 16.8 days. And you know, because this is average, mean is average. So it can be a decimal. We're expecting about 16.8 days of June to be a cloudy day. Now let's talk about the spread, the variation. To find variance, you're gonna have to multiply N, P, and Q all together. So do 30 times 0.56 times 0.44. You will get 7.392. Now, variance doesn't mean anything. We're not gonna really interpret variance, but what we use is the standard deviation. Now, standard deviation is simply the square root of variance. So take square root of 7.392. What you will get is 2.72. Now, what we can say is that this binomial distribution has a mean at 16.8, but this distribution is spread out with the standard deviation of 2.72. And remember how we use, and in this case, it will be okay for us to use that outlier rule. So I'm just gonna go ahead and well, the goal was to find mean, standard deviation, and variance. So we're done with the problem, but just to interpret this, probably not in this particular example. You know what? I'm gonna do more interpretation when we talk about normal distribution. But 2.72 days is the standard deviation. So I was gonna do about like 16.8 plus 2.72 days. So about like 95% of the day of June of the, oh, I don't know how to say this. Well, but we'll do more interpretation, guys, when we do normal distribution. But for right now, let's just stop at finding mean, variance, and standard deviation, because I think that's all you need to do for your week 7 homework number 2. But I want to do more interpretation and like word problems when we go over the normal distribution. And this example will actually be good because n is 30, but I think I want to save that part for week 8. Okay? Alrighty. That's it. That's it for this lesson. I'm going to ask you to now try week 7, homework number 2, part 2. And this week, since you're doing about 4 lesson videos and 4 different assignments, I made these homeworks a little bit shorter. Just looking at one problem. So questions like, is this experiment a binomial experiment? You decide yes or no, and you're gonna have some problems where you will have, like, you have to find the probability. They're giving you P is 21%, 12 US adults. So very similar to what we did, but you're gonna have to read them and try these, okay? Alrighty, that's it for this lesson. I will be back with more statistics by this Friday, okay? All right, I will talk to you later. Bye-bye.